Matt Trahan again. Come with the hat. So let's go ahead and turn this camera around. We're still outside with the fire, but I found a couple things I wanted to point out. If you notice over here on this side, you see the smoke is pulling in. If you look over here on this side, you'll see the smoke is pulling in again. Everything's pulling into the center. The center rises up, and there's hardly any smoke at all because, let's see if I'm able to zoom. I don't know if I'll be able. Oh, yes, good deal. All right. I want you to look at the colors of the flames in here. Now, if you cook on gas, whether it's inside the house or outside the house, one of two things. Inside the house, you never want to see these yellow and orange flames. You always want to see those blue flames. What those blue flames mean is there's enough oxygen to combine with all of that vaporized fuel that's coming off. It's hot enough that you'll notice the smoke is pretty much gone by right there. Because what happens is you get a complete combustion. There's a difference between complete combustion with the blue flames and incomplete combustion with the yellow and orange flames and all this stuff that you see on the outside. Now, what's going on right now outside here, it's in the low to mid 30s at the best. I think it's actually below freezing already. It's pretty darn cold. And what you'll see is, since the air is being pulled in from all directions, since there's no wind, the fire is able to pull wind evenly. What you'll see is that this outer circle around the perimeter of the fire, more smoke, more steam, a lot less blue, a lot more yellow and orange and red. What's happened is that cool air is being pulled in. So the fuel is cooler, the gases are cooler on the outside than they are brighter, hotter on that inside center. And as that fire continues to draw more and more heat into the center, I wish that my camera did this justice, but you'll see that the flames actually become more and more clear as they become blue, then white, and then almost invisible. If you have a hydrogen fire, not a wood fire, not a charcoal fire, but the hydrogen gas, that fire does not have any visible flames because it can only burn when there's enough oxygen. And what's going to happen is you'll have an invisible flame during the daytime, no smoke. All it has is water vapor and heat. So this fire right here, you can see a lot of yellows, a lot of oranges, but the closer we get down to the center, the lighter colored, the blues, the whites that you'll see in those flames. Complete combustion. On your house, on your stove, make sure that you only have blue flames. If you have yellow flames continuously, you need to adjust those burners, or it might be that you actually have the wrong orifice. There's two different kinds of gas that you'll cook with in a house today. You'll use natural gas, which is methane. You'll use propane. Used to be in the old days you would use butane, but by and large it's propane nowadays. If you have a natural gas orifice, the opening that the gas comes out of, it is a bigger hole because there's less fuel in that same volume than there is in propane. And so you'll have yellow flames when you use propane on a natural gas stove. But the problem that you'll have is that you'll have too much heat, too much fuel, and it could burn your house down. Yellow flames mean carbon monoxide. All that smoke means incomplete combustion. Yellow means incomplete combustion. Carbon monoxide, silent, odorless, deadly. Make sure you got blue flames inside. If you're outside on the grill and you're using your propane, your gas, I'm not going to comment on how Texas we use charcoal and wood fire to barbecue and smoke, but make sure that you're outside if you see yellow flames. Love what you got, guys. Have a safe day.